objective 1, using the temperature sensor in order to turn on an LED at a certain temperature. As you can see here, it's reading out to the serial monitor as we've written in the code. It's at 65 degrees Fahrenheit right now. I'm using my fingers to cover it up right now and try and heat it up to get it up to that 75 degrees. Once it hits that 70 degree mark, the LED comes on, and then as you'll see here, I'll wait for it to cool back down, blow it out a little bit to speed up the process, and as that temperature sensor cools back down, the LED will turn back off.
That's the power of Lexon. Bend the rules.
This is objective 2. I've just pulled this out of the freezer for sitting in there for about 30 seconds. So right now you can see the light is blue. The serial monitor is not running yet. It's stopped. It has some data in there. Once I push the button, it runs. I can then put my hand over the temperature sensor to warm it up a little bit, get it to turn to that yellow color, and then we can then go, after I take it out of the oven for a few minutes, it's now red, and I push the button and the serial monitor runs again, only when the button is pressed. Here I just wanted to quickly go over the code for objective 2. I start at the top by defining all of our pin numbers as constant integers. We go into the setup, setting up the serial monitor to communicate with the board, and instead of typing those 3 lines of code out to set these 3 LED pins up to be outputs, I went ahead and put a for loop in there to do that all in one shot. That runs through once, then goes to the other 2 pin mode, sets them up as inputs, and then kicks out of the setup, because the setup only runs once. We then move down to the loop section, where I first set up a variable called screen on, which is what I used in order to control whether the serial monitor should be showing or not from that digital push button. These are float variables because of the decimal functions of what's going on here. You need a float variable to estimate the values of what the voltage and then the actual measurements. Just makes things a little bit faster. I then move into the if statements, which I use to control the RGB LED. When the degrees in Fahrenheit is less than 50, the green and blue is on, which makes it cyan. And then inside of that we have a while loop that while that screen on button is pushed, it will output these values to the serial monitor. It then checks this at the end of that while loop to make sure it's still on, because otherwise it would never go out of this while loop, since this check is outside of the actual if statement. So we had to add this in here to each one of these to make it kick out of that while loop when we didn't want it anymore. Moving on to the next one, when the degrees in Fahrenheit is within a range of 50 to 80 degrees, we turn off the green pin, or no, we turn off the blue pin, and the green and red is high, making it yellow, or kind of a warmish room temperature color. Same thing down here with the serial monitor, it's only on when that button is pushed. And then moving all the way down to the last statement is when it is hot. So the degrees Fahrenheit is greater than 80 degrees. I had to stick it in the oven for about 30 seconds for this one. Pull it out, get a quick video before it cooled down too much. And as you can see here, I had to turn the green and blue off and turn the red on to leave it as red for that one. And then I went ahead and added this at the bottom just in case it's really hot or really cold. It'll turn all of the LEDs off, and it'll just display one thing on the serial monitor continuously saying that it's out of the temperature measurement range.